Hello everyone. Today we will see basic electrical terms. These are the contents. Phase. What is phase? We generally listen that power system is of single phase, three phase, like that. So we will see first what is phase, then what is phase difference, lagging, leading. Then for alternating quantities, what is peak value, average value, RMS value, what is frequency, and peak factors and form factor. So this is the outline of this video. So we will start with phase. The definition of phase is it is defined as the divisional part of a cycle through which the quantity moves forward from the selected origin. So in this figure, we can see one alternating cycle shown by a red line here. It is called as one cycle, and here the current phasor that is shown by IM, it is shown as a vector. Next, when the two quantities have the same frequency and their maximum, here the maximum point and minimum point, that is 0, minimum peak point here negative, both achieve at the same point, then the quantities are said to have in same phase. That means the current here we have considered the two alternating currents IM1 and IM2. IM1 and IM2. Both the quantities attains their maximum and minimum, their maximum peak point and minimum peak point at the same time, and the zero value of both here, the zero value of both the quantities established at the same point or same instant. So the quantity IM1 and IM2 are both in same phase. Next, that is a phase difference. The phase difference between two electrical quantities is defined as the angular phase difference between the maximum possible values of two alternating quantities having the same frequency. In other words, the two alternating quantities have have phase difference when they have the same frequency, but they attain their zero value at the different instant. The angle between 0 points, the angle between 0 points of two alternating quantities is called as a angle of phase differences. So from the figure we can tell that here two alternating quantities, that is current, are considered. The magnitude of both currents are respectively IM1 and IM2. The IM1 is shown by red line and IM2 current is shown by green line or green waveform. And on the left side, the vectors for current IM1 and IM2 are shown. The both vector is rotating at the same angular velocity, that is omega radian per second. The two current obtains their zero value at different instant. Suppose here where Here we can see the red waveform for current IM1 is starting at 0 or origin, but the green waveform, that is for IM2, is starting before that 0 or origin. That means we can say the 0 point of both waveform is at different instant. So there is a phase difference, and that angle of phase difference is given by phi. That is an angle between two 0 points. Therefore, they are said to have the phase difference of angle phi. The quantity, the quantity which attains its positive maximum value before the other is called as a leading quantity, whereas the quantity which reaches its maximum positive value after the other is known as a lagging quantity. We normally listen at different situations, voltage is lagging or current is lagging. That is different for inductive or capacitive loads. But here, the current IM1, which is shown by red color, it is a leading current with respect to IM2, which is shown by green color. Or we can say in other words, the current IM2, the current IM2 is a lagging current with respect to IM1. Okay. Then the cycle. What is cycle? When any alternating quantity goes through a complete set of positive and negative value or goes through 360-degree electrical degrees, then it is said to have a completed one cycle completely. So here in the waveform, we can see one cycle is given, that is 2 pi means 360 electrical degree. Okay. Here on x-axis time is there, and on y-axis E and I, that means E for voltage and I for current is taken. So on y-axis there is alternating quantities, and sorry, on y-axis electrical quantities, and on x-axis there is a time. So on x-axis time is taken, and that is here mentioned by t, but 2 pi, that is a 360-degree electrical degrees. Therefore, in here from in this figure we can say that one cycle is there, one positive cycle and one negative half cycle. Here one complete cycle is shown. For alternating quantities, we have to measure that alternating quantity with respect to in terms of peak value, average value, or RMS value. So first we will see what is the peak value. So the definition of the peak value is the maximum value attained by an alternating quantity during one cycle is called as its peak value. So here one cycle is given. During that one cycle, the maximum value attained by this alternating quantity is known as a peak value. So the sinusoidal alternating quantity obtains its peak value at 90 degrees. 90 degree means pi by 2. Here it is shown. The peak values of alternating voltage and current is represented by EM and IM. So here voltage and current E and I are given. So maximum value for E, that means EM, and for maximum value of current we can write IM. So next is average value. So what is average value? The definition for average value is the average of all instantaneous values of an alternating voltage or current over one complete cycle. It's called as an average value. That means it is nothing but the average of all instantaneous values. If we consider symmetrical wave or waveform like sinusoidal current or voltage wave, the positive half cycle will be exactly equal to the negative half cycle. In the figure, we can see the zero up to pi. That means during 0 to pi, there is one positive half cycle, and from pi to 2 pi, there is a negative half cycle. So both are exactly equal. Therefore, the average value over a complete cycle will be 0. The work is done by both positive and negative cycle, and hence the average value is determined without considering the sign. So the only positive half cycle is considered to determine the average value of alternating quantities of sinusoidal waveform. So here we are going to see one example for understanding the average value. So here the positive half cycle, that means 0 to pi, is divided into n number of equal parts. That means here it is shown 1, 2, 3 up to n. It is shown. So consider I1, I2, I3 up to In for that n number of equal parts. The n number of currents I1 to In. So the average value of current, it is given by the mean of the mid ordinates. So here the average value is given by I average equal to the addition of currents during that n number of equal parts of positive half cycle. That means I1, I2, I3 up to In divided by n number of parts. So here it is given as area of alteration divided by base. So after this we will see what is RMS value. The definition of RMS value, we can say the steady current which flows through a resistor of known resistance for a given period of time, then as a result the same quantity of heat is produced by alternating current when flows through the same resistor for the same period of time is called as a RMS or effective value of the alternating current. It is also known as the square root of means of squares of instantaneous values. So consider I is the alternating current flowing through a resistor R for time t seconds, which produces the same amount of heat as produced by direct current, that is DC. The base of one alteration is divided into n number of equal parts so that each interval is of t upon n seconds. So here, like average in average value, we have seen the first positive half cycle is divided into n number of parts 1 to n, and during that n number of parts the current is distributed among that parts, that is I1, I2, I3 up to the In, and that one interval is of t upon n. T is the time duration of that positive half cycle, and n is the n number of equal parts. So here for RMS value during the first interval, the heat produced is I1 square RT upon J and cap. Like that, for second interval, third interval, up to nth interval, we have derived that current heat produced, and from that we have calculated the total heat produced, that is RT upon J in bracket I1 square up to IN square upon N, and unit of that heat produced is in calories. Here we have considered that this equation is equation number 1. Since the DC current or effective current is considered as the effective value of this current, then the total heat produced by this current is, we have considered I effective square RT upon J, and unit is in calories. So now if we are equate the equation 1 and equation 2, we will get the I effective square RT upon J equals to RT upon J in bracket I1 square to IN square upon N. So we will get I effective at the end, we will get I effective equals to square root of mean of squares of instantaneous values. So it is the actual value of alternating quantity which tells us an energy transfer capability of an AC source. The ammeter records the RMS value of alternating current, and voltmeter records the RMS value of alternating voltage. The domestic single phase AC supply is 230 volt 50 Hz, where the 230 volt is the RMS value of alternating voltage. The values of voltage and the current system in a DC circuit is constant, so there is no issue in evaluating their magnitudes. But in AC system, the alternating voltage and current varies from time to time, and hence it is necessary to evaluate their magnitudes. These three ways, that means peak value, average value, and RMS value, are adopted to express the magnitude of alternating voltage and alternating current. So next is frequency. So frequency is the number of oscillations per unit time. It is used for defining the cyclic process like rotation, oscillation, waveforms, etc. The completion of the cyclic process at particular interval of time is known as the frequency. The SI unit of the frequency is hertz. The 1 hertz means the wave completed one cycle in 1 second. So we can also write like that, number of cycles per time. The traditional unit for measuring the cyclic process is revolution per second, which is equal to the 1 hertz. From the figure, we can see there are 5 half cycles. In that, 3 are positive half cycles, 2 are negative half cycles, and we can uh, uh, we can say that for 1 second time, the number of oscillations or number of cycles are 2.5. Therefore, frequency upon, sorry, number of cycles per time, that means 2.5 upon 1 second. Therefore, frequency will be 2.5 Hz. The frequency is the parameter which explains the frequency. The frequency is the parameter which explains the phenomena of oscillatory and vibration like mechanical vibration, sound signal, light and frequency waveforms. The term period represents the time required by the waveform for one oscillation. So therefore we can say that it is inversely proportional to the frequency. We can also say that period is nothing but the time. So time is inversely proportional to the frequency or vice versa. Frequency is the inversely proportional to the time. Frequency is the total number of oscillations per unit time. Next we will see peak factor. The peak factor is defined as the ratio of maximum value to the RMS value of alternating quantity. Simply, it is the ratio of maximum value to the RMS value. The alternating quantities can be voltage or current. The maximum value is the peak value or the crest value or the amplitude of voltage or current. The RMS value is the amount of heat produced by alternating current will be same when DC supply is given through the same resistance in the same given time. The peak factor is mathematically expressed as Im upon RMS, that is maximum value of current upon RMS value of current, or for voltage Em upon ERMS, that is maximum value of voltage upon maximum value of RMS value of voltage, where Im and Em are the maximum value of current and voltage respectively, and IRMS and ERMS are the RMS, that is the root mean square value of alternating current and voltage respectively. For the peak factor, for the current varying sinusoidally, the peak factor is given as Im upon IRMS, and IRMS can be replaced by Im by root 2, that is the maximum value of current upon root 2. If you replace that instead of IRMS, then we will get peak factor equals to root 2. The value of root 2 will be 1.4142. This is the value of peak factor. And last point is the form factor. So definition of form factor is the ratio of RMS value to the average value of alternating quantity, that is current or voltage. It's called as a form factor. The average of all instantaneous values of current and voltage over one complete cycle is known as the average value of alternating quantities. Mathematically, the form factor is given as form factor equals to IRMS upon I average or ERMS upon E average, where the IRMS and ERMS are the RMS value of current and voltage respectively, whereas I average or E average are the average values of alternating current and voltage respectively. For the current varying sinusoidally, the form factor is given as IRMS upon I average. If we replace the IRMS and I average by their equivalent values, that is Im by root 2 for IRMS and 2 Im upon pi for the I average. So for that we will get pi into Im upon 2 root 2 Im, and finally the form factor value will be 1.11. So the value of form factor is 1.11. There is a relation between peak value, average value and RMS value of alternating quantity. Therefore, to express the relationship between all these three quantities, the two factors are used, namely as peak factor and form factor. The form factor for various sinusoidal waveforms are given here. For sine wave, it is 1.11. For half wave rectified sine wave, it is pi by 2, that is 1.57. For full wave rectified sine wave, it is pi upon 2 root 2, that is 1.11. For square wave, it is equal to 1. For triangular waveform, it is 2 by root 3, that is 1.15. And for sawtooth waveform, it is also same as triangular waveform, that is 1.15. So this is all about the phase phase difference, then peak value, average value, RMS value, frequency, time period, and peak factor, also form factor. Thank you for watching this video.